Welcome back to another one of my applications of differentiation videos. This will be focused on the Rolle's theorem, or Rolle's theorem, whatever. And this is the fourth episode, and we'll be focusing on cosine in this one. So let's hope I've got enough ink left in my pens, or if they're not rubbish. So example 1, we have function equals cosine of x within the interval of pi on 2 and 3 pi on 2. Okay, so to graph that, basically the cosine function, you can use the unit circle with this, or you can use the just graphing it. I'm going to graph it. So this is 1, this is -1, and this is 0. The cosine function, I'll just draw these points up as well. This is pi on 2. This here is pi. And this here is 3 pi on 2. And if we keep drawing this one more, we will get 2 pi. And the cosine function it's actually humanly impossible to draw a perfect sine or cosine function, but that's close enough. So that's basically what it looks like. It keeps on going and on, but we're only looking at this point and this point. And first, with the criteria, I'm not going to go through them, writing them out, but I'm just going to say it is continuous on the closed interval between these 2 points from A to B, and it is differentiable because any cosine and any sine, any standard cosine and sine function are differentiable along the whole lot and continuous along the whole lot. Okay, the only thing we're worried about is if this point equals this point, and we already know that because it's cosine, it's a cosine function. It's not hard to tell. At pi over 2 it is 0, and at 3 pi and 2 it is 0. I could do it up for you if you want, but just type it into your calculator, because these will be our point A and this will be your point B. And if you have A equals pi on 2 and you sub that in, you'll just get 0 if you sub that into that function. And same for B equals 3 pi on 2. The function of B will equal 0. So f of A does equal f of B. But if you're familiar with trigonometric functions, you should really know that anyway. But if you're not, I guess you learnt something. So what we're looking for is the point at which we know that the slope going across here is the same. It's 0. Therefore, we're looking for a point at which the slope is the same as that slope there. Going through these points, the slope should be the same. So we're looking for the point where that is. And if you know trigonometric functions, it should be pi. So we're sort of just proving that pi is where the point is, and sort of proving the function in a way. Anyway, so we've proven this. Now it's basically saying that the derivative of f of c will equal 0. So let's find the normal function of c and then derive it. So function of c, just replace all the x's with c's. So that's cos of c. And the derivative of cosine is negative sine c. Okay, and now we set it to 0. So let derivative of c equals 0. 0 equals negative sine c. Okay, so if you times -1 on both sides, you basically cancel out the negatives, and this will cancel out because it'll just stay at 0, because anything times 0 is 0. So that's essentially a negative. Just 0 equals sine c. And how do we get c on its own? Well, inverse of 0 will give us c. Well, you could do it that way, or you could do it this way. Because if you're familiar with trigonometric functions, it just makes it easy just to look at it and understand it a bit. If you look at sine c, at what point when you sub into sine, what x value equals 0? Okay, so if you look at another graph of the sine function, it comes up, goes down, and it comes back up again. And this is 0 here. This is 1, and this is negative. This is negative 1. Okay, and this is pi on 2. This is pi, and this is 2 pi. And this over here, well, this is just 0. It's a starting point. Okay, so you can see this is, I'll just write it up, this is sine x, and this is cos of x. Sine x, at the x value of 0, you type in sine 0, it comes up as 0. You type in sine of pi, and you get 0. You type in sine of 2 pi, and you get 0. So basically you have 3 points, 0, pi, and 2 pi. So at 0, sine 0 equals 0. At pi, sine of pi equals 0. And at 2 pi, sine of 2 pi equals 0. Okay? And because the domain we have is between pi on 2 and 3 pi on 2, we don't care about anything else. So we can basically scratch out the 0 value that's over here. We don't want that. And we don't want the 2 pi because we're just looking between here. So the only value we can see is pi. Therefore, this doesn't work because it's not the domain. This doesn't work because it's not the domain. This must be the answer. So c is equal to pi. And that's it. Which is just proving it in a sense. Because at pi, which is halfway between this and this, if you come down the point, the slope will be the same as the slope going through these 2 points. Okay? And so pi is the same as c. Alright, well, I hope that wasn't too confusing for you, and I hope you learnt something a bit about trigonometric functions and Rolle's theorem. But anyway, thanks for watching. Have a good day.